Okay, people, my name is Dana. This is my very first YouTube video ever. I've got something here that I don't quite understand, and I'm hoping maybe someone out there can explain it to me. I've been doing a lot of research on the flat Earth and the firmament, things like that. This is a set of encyclopedias I have. They're Encyclopedia Americana. This is volume 2. It's the A's. What we're going to do is look at what it says about Antarctica. These, just remember, this is a 1958 edition. Okay, this was before the Antarctic Treaty was signed. This was before the supposed Apollo missions. I want to show you something that it says in here about Antarctica. It basically talks about all the exploration. It says here, Antarctic regions, all the exploration. Has a few photos, not too many. This is the map created back then. I've read all of this. This is the part here that I have the question about. I am trying my best to get some light on here really good. Like I said, this is my first video. Don't criticize me too much. I have no idea what I'm doing. Let's see. Okay, I hope you can see this. They did flights, and it says, these flights prove the inland areas to be featureless in character, with a dome 13,000 feet high at about latitude 80 degrees south, longitude 90 degrees east. Okay, I have no idea what that means. There seems to be only one definition for the word dome. Anyway, if anybody has any idea what this means, can explain this to me, I would appreciate it. Okay, thanks.
There's another recent article that just I found, I think it was on the 14th, and I posted it on Facebook, called "Are They Finding the Firmament?" Now, I started out with, meanwhile, as people suffering from severe cases of impenetrable cognitive dissonance who think that discussing what the Bible has to say concerning our Earth and its place in the cosmos is a waste of time, scientists at MIT may be confirming the scriptures right in front of us, for us. This is a quote from an article taken from ibtimes.com, and I've got the link there for that. It says, the Earth is protected from fast-moving killer electrons by an invisible plasma shield, which is located thousands of miles above the planet's surface, according to researchers at the Massachusetts Institute of Technology, MIT, and the University of Colorado, Boulder. High above the Earth's atmosphere, harmful electrons that make up the outer band of the Van Allen radiation belt travel at nearly the speed of light, pelting everything in their path. Exposure to such high-energy radiation can harm satellite electronics and pose serious health risks to astronauts. However, despite their intense energy, these electrons circling around the planet's equator cannot come below 7,200 miles from the Earth's surface due to the shield, scientists said in a study published in the journal Nature on Thursday. It's almost like these electrons are running into a glass wall in space, Daniel Baker of the University of Colorado Boulder and the study's lead author said in a statement. Somewhat like the shields created by force fields in Star Trek that were used to repel alien weapons, we are seeing an invisible shield blocking these electrons. It's an extremely puzzling phenomenon. The invisible shield, dubbed the plasmaspheric hiss, is made up of very low-frequency electromagnetic waves in the Earth's upper atmosphere. Scientific data and calculations have helped researchers deduce that the hiss deflects incoming electrons, causing them to smash into neutral gas atoms in the Earth's upper atmosphere and ultimately disappear. It's a very unusual, extraordinary, and pronounced phenomenon, John Foster, Associate Director of MIT's Haystack Observatory, said in a statement. What this tells us is if you parked a satellite or an orbiting space station with humans just inside this impenetrable barrier, you would expect them to have much longer lifetimes. That's a good thing to know. The latest study is based on data collected by NASA's Van Allen probes that are orbiting within the harsh environments of the Van Allen radiation belt. Oh, you mean the one that they just flew through, no problem, back in the 60s? In the 70s? During the study, the researchers observed an, quote, exceedingly sharp barrier, end quote, against harmful electrons, which was steady enough to withstand a solar wind shock in October 2013. To determine what could create and maintain such a barrier, the researchers considered a few possibilities, including effects from the Earth's magnetic field and radio signals from human transmitters on Earth. Oh yeah, it's our Walkman that's causing this. Whatever. You know, and there's another article I should post where they're saying they basically want to poke a hole or blow up or eliminate even the Van Allen belts. Okay, check this out. February 27, 2014, okay, last year. Physicists plan to wipe out Earth's Van Allen belts with radio waves. Got a depiction here of the Van Allen belts, what they look like here. It was just last year that physicists thought they had found the origin of Earth's Van Allen radiation belts. And now, a prominent group of them wants those belts dead. It's understandable, given the frustration these areas of space can cause to modern astrophysicists. If you want to launch a satellite or a telescope, let alone a human being, the Van Allen belts will be a painful thorn in your side. So, says a growing group of astrophysicists, why not wipe them out altogether? Everybody seems to agree that these belts are good for us, you know, that they're doing something. They were intended to be there. This place was created with these things around us for a reason. Okay? And these knuckleheads, hey, I think we should just blow it up. I don't really think it's important. I don't know what it does, so let's blow it up. And it's not the first time they wanted to do that. In fact, you could go do a Google search on going nuclear over the Pacific, Smithsonian.com, and learn about Starfish Prime and Operation Fishbowl and all that. It says here, knowledge of radiation in space was still fragmentary and new. It was only 4 years before that, James Van Allen, a University of Iowa physicist who had been experimenting with Geiger counters on satellites, claimed to have discovered that the Earth was encircled by a deadly band of X-rays, and that radiation from the sun hit the satellites so rapidly and furiously that the devices jammed. Van Allen announced his findings on May 1st, 1958. Go back and look at what was going on in 1956 through 58, specifically what was going on in Antarctica with Operation High Jump and Operation Deep Freeze. And then everybody pulled out of Antarctica, they all signed the Antarctic Treaty, and NASA's then created, and all of a sudden Van Allen, you know, does this little experiment when they start shooting stuff up into space, and he finds the Van Allen belts. At a joint meeting of the National Academy of Sciences and American Physical Society, and the following day, the Chicago Tribune bannered the headline, "Radiation Belt Dims Hope of Space Travel." The story continued, death lurking in a belt of unexpectedly heavy radiation about 700 miles above the Earth, today dim man's dream of conquering outer space. Okay, so this was early on in the creation of NASA and the whole space program. This is, if it's 1958, it's even before Kennedy made his announcement to want to go to the moon. But yet 700 miles above the Earth is this thing that seems to prohibit that.
We are headed 3,600 miles above Earth, 15 times higher from the planet than the International Space Station. As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation.
What?
As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation.
One more time.
An area of dangerous radiation.
Oh. What's wrong with that radiation?
Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back.
That doesn't sound good.
Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space.
What? We must solve these challenges before we send people through this region of space? I thought this problem was solved over 40 years ago when he sent a bunch of people in jumpsuits and tin cans through it there and back a half dozen times. But I forgot the Apollo guys. They were clueless regarding the radiation belt. That it didn't affect them.
I don't know the distance to the Van Allen radiation belt, and if we did, it wasn't a problem. If we were going to encounter it, then we would have had to build the spacecraft and the spacesuit to not give humans a problem. You don't just build something and hope it works. You study to see what the threats are, the environment is, and then you say, how thick do I have to make the metal on the spacecraft so that going through this kind of radiation or these kind of meteoroids, it won't get hurt. And then we build it that way.
The belts are 1,000 miles to 25,000 miles above the Earth.
Then we went right out through them.
No effects on your cells?
Didn't even know it. I don't think anybody, well, maybe somebody said you went through the radiation belt, but we didn't feel it inside, and we didn't get any, added radiation.
So apparently you had this magic window of time, because now Orion's still very much concerned about it. We've got to solve this challenge before we can put people through it. And yet even before Mercury and Gemini, they were very concerned about it and trying to figure out how to solve the problem, as evidenced in this Smithsonian.com article. News of the hot band of peril immediately cast doubt on whether Laika, the Russian dog, would have been able to survive for a week in space aboard Sputnik 2, as the Soviets claimed in November of 1957. The Soviets said that after 6 days, the dog's oxygen ran out and he was euthanized with poisoned food. It was later learned that Laika, the first live animal to be launched into space, died just hours after the launch from overheating and stress, when a malfunction in the capsule caused the temperature to rise. What Van Allen had discovered were the bands of high-energy particles that were held in place by strong magnetic fields and soon known as the Van Allen belts. A year later, he appeared on the cover of Time magazine as he opened an entirely new field of research, magnetospheric physics, and catapulted the United States into the race to space with the Soviet Union. On the same day Van Allen held his press conference in May 1958, he agreed to cooperate with the United States military on a top-secret project. The plan? To send atomic bombs into space in an attempt to blow up the Van Allen belts, or to at least disrupt them with a massive blast of nuclear energy. Okay, guys, read up on this stuff. All right, this is Smithsonian.com. Check that out. There's another good article on NPR. You can look up a very scary light show, exploding H-bombs in space, title for after they find something in Antarctica, which the flat earthers would say is the outer rim of the circle of the Earth. And everybody pulls out. All of a sudden, NASA's created. And right after that, they start shooting up rockets into space with nuclear warheads on them. And this is what you start seeing with Operation Fishbowl. Operation Fishbowl. Really?
All right, now here's a headline you just don't see every day. Nuclear blast tonight may be dazzling. Good view likely. Almost 50 years ago, from a small island in the Pacific, the U.S. government conducted a test. It was one of a series to find out what would happen if you explode a hydrogen bomb above the Earth's atmosphere in outer space. It was the height of the Cold War. And in early July 1962, this Thor rocket carried a bomb 1,000 times more powerful than the bomb that hit Hiroshima up into the sky, 250 miles up. Other rockets then followed to monitor what was about to happen. And then there was an enormous white flash. Here's a view from another camera. The sky flashes red and green as particles from the bomb drop back into our atmosphere. Green is what happens when radiation collides with oxygen atoms high up in the ozone layer, and blue is when particles strike nitrogen atoms in the thicker air. So here's another view, this one from the ground. This is not a sunset. This is maybe the greatest man-made light show that we never want to see again.
I mean, it looks like they found something in Antarctica, and they said, "Oh, what is this? Wonder how high it is. How high does this thing go?" And they start blowing off nuclear bombs in the atmosphere. Now, were they doing that because they were testing the firmament? Were they trying to blast through the firmament, or is it about the Van Allen belt with the radiation? Is that the problem? I don't know. This article goes on to describe, again, the Van Allen energy belts and what they came to understand about them, and discover it, then blow it up. The plan was to send rockets hundreds of miles up higher than the Earth's atmosphere and then detonate nuclear weapons to see, A, if a bomb's radiation would make it harder to see what was up there, like incoming Russian missiles, B, if an explosion would do any damage to objects nearby, C, if the Van Allen belts would move a blast down the bands to an earthly target, Moscow, for example, and most peculiar, D, if a man-made explosion might alter the natural shape of the belts. The scientific basis for these proposals is not clear. Fleming is trying to figure out if Van Allen had any theoretical reason to suppose the military could use the Van Allen belts to attack a hostile nation. He supposes that at the height of the Cold War, the most pressing argument for a military experiment was, if we don't do it, the Russians will. And indeed, the Russians did test atomic bombs and hydrogen bombs in space. No big surprise, they were also down there in Antarctica prior. And oh, by the way, while we supposedly got ahead of them and started to beat them in the alleged space race, you know, we're led to believe they just, we lost and they gave up. No, they sent something like 40 missions down to Antarctica while we were playing around with the so-called Apollo space program. So something's going on here, and these psychopaths, you know, they look up there, they see something, oh, that looks cool, let's blow it up. Oh, we don't really think it's important, even though they have admitted that they know it's there for our protection. Anyway, let's go back to the original ibtimes.com article regarding the invisible plasma shield. The last quote here says, it's like looking at the phenomenon with new eyes, with a new set of instrumentation, which give us the detail to say, yes, there is this hard, fast boundary, Foster said. Have they found the firmament? I don't know. I mean, it's not exactly the description of the firmament, but if it's not the firmament, it may be one of the heavens and the layers below it. But whatever the case may be, the choice of words being used, as I've stressed here in bold above, seems more than interesting to me. A hard, fast boundary that is an impenetrable barrier out there about 7,200 miles up? Note also the repeated statements about how harsh space is and in and beyond the Van Allen belts. And yet we were told NASA sent a bunch of guys in jumpsuits and a tin can through it 12 times round trip on at least a half dozen alleged missions to the moon. Job 37:18 says, hast thou with him spread out the sky which is strong as a molten looking glass? Amos 9:6 in the New American Standard Bible says, the one who builds his upper chambers in the heavens and has founded his vaulted dome over the earth. He who calls for the waters of the sea and pours them out on the face of the earth. The Lord is his name. There may yet be a legitimate reason people are going back to the scriptures in order to see and test/prove 1 Thessalonians 5:21 the truth for themselves.
So I'm just out in my yard. A lot of people forget that you can create your own rainbow if you just turn on a sprinkler. And if the sun is angled the right way, only when you're outdoors, you will get a rainbow. So that's the first question. Why can you not simulate a rainbow indoors? There's a stipulation. You can create a rainbow indoors, but you need a mirror. You need a mirror to do a science test and create a rainbow inside. So I beg the question, if you need a mirror indoors, what's providing the mirror when you are outdoors? And I don't know if you see this, but it really doesn't matter. It really does not matter about the water, where the mist is. Doesn't matter what my position to it is. The curve does not change. It is a fixed hologram in space. Now, modern science says what's happening is an optical illusion. It's forming on your eyeball, and I guess in this case they would say it's the camera's sensor. But they say that a rainbow is happening on your eyeball. You're having your own unique experience. When you see a rainbow, the person standing next to you won't have the same experience. That's what they claim, because they say each water droplet is creating a prism that is taking the white light and separating it out into all the different colors. I don't think that makes any sense, guys. I think what's actually happening is that each water droplet of this 3D field, each water droplet is acting as its own lens. And so this lens is going to be slightly different from this lens. Not that each water droplet is projecting its own rainbow. That's totally absurd. So each water droplet is a lens, and it exists on a 2D plane, right? I mean, I can walk right through it. Here, I'll walk right through it. No, I've got my camera. That's just a really stupid idea. But we've got a 3D field of vapor, right? This is 3D going back and forth, but the rainbow only appears on this 2D XY axis. And so the sun is there, and the sunlight is providing one line of sunlight. If it's a 2D line on a 3D spectrum of vapor points, modern science says that there should be thousands or millions of rainbows all along this axis. But there's not. There's just one rainbow on a 2D surface. So that means that one line is converging here and another line is converging somewhere else. There is a mirror when you are outside to create the rainbow. And that mirror is the dome. It's catching sunlight and it's meeting itself to create all the various colors. It collides in the water droplet, serves as a lens, and the slight variations of angle creates the colors of the rainbow. A rainbow proves that there's a dome above your head.
I'm going to run this. This is running at 50% speed, and I'm going to give you one more with filters added. And there's the wave again. It's a great shot because it is the first time we get to see a zoom up close on the moon of the wave, and there it is really slowed down. I always shoot wide because I want the whole moon in frame, but all this footage really adds something to what we know. Now what you need, look to the right there. See that noise coming into frame? He shot at a lower resolution, and when I ran these filters, right before the wave begins, we get that noise off to the right of the moon, and it occurs a couple of times as the wave is traveling. There's the first wave coming down from the top, and there's the second wave. What you should do is look out at the outer limb of the moon, and when you see it pass, look at the lower left corner, and you'll see the wave cross. So look at the outer right edge of the moon, and there's the wave. Now glance into the lower left, and you'll see the wave come through that corner. Here it comes now. And you'll see the wave go up the upper right limb of the moon, follow the arrows. Remember where this is. It's the only time I use an arrow to indicate. But here you see 3 waves, and then there's even a bit more than that. But the astounding thing about this footage is when I put the filters on it and zoom in later, you can really see it traveling across the face of the moon. You can see the curvature. And here we go again. And as you see the wave on the outer limb, well, maybe not on this footage. The best place to see this particular footage is out on the outer limb of the moon. And there's the third one coming up. So let me get the filters applied here, and then what you'll do is glance into the face of the moon, and you'll be able to see the wave traveling. Okay, look to the outer limb so you can identify where the wave is starting. There's one. And glance into the face of the moon. You may have to stop and rewind, but you can completely see the wave traveling across the whole face. I reviewed this footage for a good 4 or 5 days. I forget now, but it was quite a bit because it was the first conformational video I'd been handed, so I wanted to be darn sure that I was looking at. Now in this footage you can really see the waves traveling across the face of the moon. I've applied some filters and brightness and contrast. So this is the only example of 3 waves we have. There it is backwards, and then I'm going to run it forwards again. So here it comes at the bottom. The wave comes in, it goes out of frame, and then catches up to the camera, which has always meant this was never an equipment failure, not to mention that it's an organic wave and digital instruments don't fail that way. Okay, here comes the wave. There's wave number 1. Okay, and it's getting ready to come in from the top here. And there's the first wave. And you can see it bowing around the moon. And here it comes. There's the first wave from the upper left. And there's the second wave. All right, the 2012 footage, which we're going to go over here, is the most important footage I've ever shot. And just because of the way this footage was shot, it allowed me to understand, after I figured it out, that this is a filmed event. Look at the bottom, and I'm going to run with some filters first to show, the prominence of the wave over the face so that you can see the curvature. And then I'm going to break this out so that you can see the energy pulse that happens on the lower left limb of the moon just as the wave is about to begin. And bear in mind, 4 seconds after the first wave, an object goes up the upper left limb. So here we go down to the bottom left to see the pulse that occurs. There's backwards and forwards, and you can see the curvature of the pulse that happens, the energy pulse. Now as it goes up a little, you're going to see a sweep across the face of the moon. There it is backwards. It goes from left to right. You can see just kind of an energy sweep occur. All right, here we go again. And you can see the energy sweep. And then the wave starts up. And you can completely measure the bow of this going around the sphere. It's a measurable thing. And if you consider that each pixel has a value in distance, it's probably quite a bow. The problem is I don't know what the distance of the moon is, and I have a feeling it's much closer than we've been told. But saying that and proving that are two different things. The grid overlay matches the tilt of the wave from our point of view. Here's at 150% with the grid layover to indicate the angle from our point of view of the wave traveling over the lunar surface, if there is such a thing.
So, what happens at about 1 minute and 6 seconds on the first camera is, the rocket flies up, yo-yo device goes off, you can hear it, and the spinning stops, and then it's just kind of sitting there as it's reached its max height, and it's going to start falling back to Earth. On Balls Out Physics episode 2 and 3, I can't remember which one at the moment, but I linked the video to I think it was called Human Universe, a BBC series where Professor Brian Cox came from the UK, the United States, to do an experiment with a bowling ball and some feathers in NASA's vacuum chamber at the Glenn Research Center, and they show how in a vacuum both objects fall or accelerate towards Earth at the same rate. So the same thing should happen here. Both of these objects should accelerate down at the same rate, unless they're in a liquid, because this one would be more massive, so it would fall faster, or unless they were forced apart by the stage separation. That would create a force and an acceleration, or an increased acceleration on the bottom stage. But if you go to about 3 minutes and 46 seconds, where you see the yo-yo device go off, and then wait another 10 seconds to about 10:55 or 3:55 to 3:56, you hear the stage separation and you see the ice fly off, and you can also see the horizon from the way the camera's orientated. And I've watched this over and over again, and I do not see any acceleration from the separation. I do not see this piece accelerating up. And to have a force, you have to have an acceleration, because F equals ma. It does not appear like there is a force pushing these two pieces apart. And then if you watch the video throughout, you can see every now and then the nose camera catches the engine, and it's significantly farther down, or it's dropped significantly farther than this nose piece is. This nose piece, which you would think it would be very light, just kind of almost seems like it's floating, like there's buoyant forces acting on it. And this was really the premise of what I was talking about in the first episode. I didn't get into the fact that the acceleration of the engine appears to be greater than the acceleration of the nose. I mean, that's definitely true whether it's created by this force or they're in a liquid, and because this is more massive, a liquid or a gas, because this piece is more massive, it's falling faster than this piece is, because buoyancy is having a greater effect, or buoyant forces are having a greater effect on the nose, if you want to look at it that way. So, to me, it does not seem like there is a force in the stage separation. So, I think this is falling faster because it's in a liquid. And then another thing, there's ice crystals all over the outside of the rocket. Now it gets cold as you go up, but in the thermosphere at 117 kilometers, bringing back this chart that you might be getting tired of seeing, go fast as here, temperature 200 degrees Celsius. Now, as we're told, in the thermosphere, you should see a cold temperature, so I guess the ice crystals could stay there. But still, listen to the sounds. It seems like there's some kind of liquid up there. It really does.